Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh and very good morning. Thank you very much for being here for another webinar series of aerospace.
Okay, Tia Siva, probably you can start the session. Thank you.
I would like to thank all of the distinguished participants for today, and a very good morning, selamat pagi, and assalamualaikum warahmatullahi wabarakatuh to all our friends. Special thanks to IR Professor Rahim from UniKL Aerospace Department, myself organizing this webinar. Also, special thanks to my dear friend Mr. Abdullah for his participation in making this. We have some house rules we obey throughout this webinar. Size, so that the webinar can go on smoothly. Please ensure that the microphones are switched off during the webinar. Switch on only when needed. When you require to speak, when you have a question that you need to ask. The camera if possible as well. When someone else is talking, please do not interrupt, of course. You can also post questions in the chat box in case you are unable to communicate. Maybe you have problems with microphones, so on. We would like to take this opportunity to invite all qualified, all those who are qualified in the field to register with the Technology Association of Malaysia 10 and Malaysia Board of Technologies Hamburg. These are the two governing bodies in Malaysia which are quite active in the professional field. This can greatly enhance actually our credentials, bring professionalism into the industry, and thus better uplift the society of engineers and technologists in the country. Please do visit the website for more details. Alright, without any further ado, let us begin this webinar. The topic for today is Aerospace Composite Structure Certification. This is organized by UPM, MySET, UniKL MIAT. The talk will be presented by our eminent and distinguished speaker, Respected Professor IR TS Abu Hanifah Hj. Abdullah.
Assalamualaikum. Good morning and selamat sejahtera to everyone. My name is Abu Hanifah Hj. Abdullah. I have been in the aviation since 1989. It's about 30 years now, and I started my career with Aerospace Composite as a technical service engineer. And then I moved to Australia. I worked for the Eagle Aircraft International, design and certification of composite aircraft. And in 1996, I came back to Malaysia and I joined Department of Civil Aviation, Airworthiness Division, until I retired in 2009. And 2009 onward, I worked for the University of Kuala Lumpur, Malaysian Institute of Aviation Technology. So I have some years of experience in aircraft design and certification, and one of the area which is I have been working with is on the design and certification of composite aircraft. So this session is sharing session, based on my previous years of experience in design and certification of aircraft, and for this session specifically, I will focus more on the composite structure. And as for participants' information, Malaysia do have several aircraft being certified. We do have Eagle Aircraft, which has been certified in Australia, and the design and the facility has been moved to Malacca, and they have this eagle now is being certified in Malaysia. Malaysia issued a type certificate for this aircraft, and this eagle is 100% composite. The only metal is the engine frames and the hinge brackets for the control system. The rest are all composite, including the landing gear strut. Also, we do have SME MD3 160. That is a fully metallic aircraft. However, it has a very unique wing, which wings is bonded. Is bonded means there's no rivet, so there's a core, honeycomb core, and the skin bonded. So it is also quite an issue in terms of bonding, which is a very important aspect of composite design certification. And we do have also several years of project Aeronimbus. Aeronimbus is very light jet. They have been working for several years on this project. However, it did not get through the certification, and the project was basically, I think, disbanded. It's been quite a number of work been done, but has not that many certification work on this aircraft yet. And we also do have, still remember, we do have Jetport, so which has not been through any certification process with the CA. However, they came to see us to explain that they are developing this aircraft. So that is about what we have in Malaysia. And we do have several large manufacturing organizations like ACM in Bukit Kawihitam and CTRM in Melaka, making parts and components for the OEM. And they are just manufacturers, and they don't have any design certification with them. So that's about it. I would like to just share and explain how the composite structure has been certified. I'll go through a bit on the design requirement, and I also explain the basis of the design requirement. So this is about it. That is what, and also the last one here, we do have also a very good project of design and certification of diplomatic locker, which is used by the A320 with the AS. Yeah, I just share with you later on how we get this thing done. So the objective of the talk is sharing session, sharing experience on certification manufacturing control. I will mention about the Eagle, which is resin system, the way layup, the testing, UV protections, and composite material quality validation and supplier control. I also later on share about the Lancair issue on class transition temperature, and also Lancair is very unique at that time. It was the first few aircraft was manufactured under the type certificate. I'll mention about it in a bit. Diplomatic worker of A320 development of certification basis, because there is no basis to certify the diplomatic worker. It's a unique, it's not aircraft part. And also there is a few issues on the type validation on Diamond 40 and 42. And the end of the session, this is very brief session, and is a wide area. It's not very specific, but at least at the end of the session, the participant will be able to find where are the airworthiness requirements. If you are working on design or repairing aircraft related to composite structure, after having the session, at least you will be able to see where are the airworthiness requirements that you need to focus and where they are. And also briefly, as we go through, I will explain a bit on how we get this thing done based on the requirement, and how we get through it, how we show the compliance to those requirements. Let's begin with the certification process. On the, you can see the slide on the right, that is an Eagle aircraft, very beautiful, fully composite. Uh, they call it canards, but however, most people argue about it because the size is so large and it's almost similar to the wing, the main wing. And some somebody say this is the two wings aircraft. So it's just like staggered by plane. It's very interesting aircraft. I will go through a bit on this because I have experience on this, and also the knowledge that we have as we go through here also applicable for any other aircraft category as long it is composite. You can see on the left, this is the chart how product been certified. So if this is the standard that we use. EASA has been using this all a while, and CAA Malaysia also been adopting this, and most of the country in the world also has been using this methodology of flows of how to get product being certified. So let's go through it a little bit on this. You can see here on the left, on the right top corner, product spec. So product spec is in isolated box, mean that whatever you think you want, based on your customer or based on your mission requirement, you design the product. Do not think of the certification requirement, do not think of any other limitation. And this is on the left here, you can see the whole chart here. This is the certification process for aircraft, for products. And it begins with the product spec. As we do start designing something, we have to develop the concept of products, and without thinking of the certification, without thinking of the technology, and this is innovation, is innovative. Then after we have decided that is the product, because the aim during the product specification is the customer requirement as also or mission control. Mission requirement. So customer requirement, if you are design something selling at mass market, then it's you have to look at what the mass of the customer is looking for. For mission requirement, if you are design any product specific for function, for specific organizations. After that, we go into the item number 2. Then we go negotiate with the certification authority on what is the certification requirement that you will need to go through, to follow. And one of the factor in this, one of the element inside the certification basis, the awareness requirement. Then after we have decided and we have agreed on the awareness requirement to be used in the design, then we go into the detailed design. And detailed design for the structure, we have to show compliant either by analysis on or test, and later on I will also explain as we go through this the talk, and you will see the area of analysis and test required. For the structure, specifically for the structure, generally we need to have the load, we have to study the stresses, we have to do the stress analysis to study the stress, and also we have to validate by test. If analysis is sufficient, we can just use analysis. If not, we have to go to the test to validate the analysis. At the same time, during the test and during the analysis, for the test, the type certification authority have to work together with the design or with the OEM, you or the applicant for the design. What you need to do, you have to develop the test plan, and you have to submit the test plan to the authority for their approval. And then you have to plan for them to witness the test. As you do the test, you have to invite them to witness the test. And if they are not available, they may delegate the witness to you. However, for very significant, very important parts and component, they will be available to witness the test. And once the test completed, you write the test report and they have to approve the test report. So that process in the certification, we call it type investigation. So here is the type investigation program. Then after you do the test analysis, you complete the compliance checklist document. The compliance checklist document basically is the matrix of showing compliance for each requirement being specified in the awareness requirement, which we have decided in the step 2 earlier. So this is the whole process, and briefly, every design of the aircraft, component, anything that you go through in design for the certification. So this is the process, and this is how you involve and how the authority is involved before you get the certificate. Once you got the certificate, the certificate, the type certificate or type approval is accompanied by the type certificate data sheet, where in here it could be the detail. If you are unable to get the design fully complied, all the limitation will be spelled out in detail in the type certificate datasheet as well as in all other manuals. For example, early development of the E-diamond, and they have problem with the resin, which the temperature is sensitive to the glass transition temperature is sensitive to the ambient temperature, and they have limitation on the operation of the aircraft. So this is example. Next, let's just go look at briefly what is structure design. What we do in structure design. So structure basically the main component of the aircraft. Without the structure, is no aircraft. So the structure is loaded due to the weight, and the weight have to be balanced in equilibrium to the lift. And also, as this body is the object flying in the air, we have the drag forces and the thrust will be encountered there. So these are the loads on the aircraft. The load will turn into the forces, and the force will act on the structure, and we need to disseminate all these load and forces into the structure, and this is a complex structure. If you look at this is a metallic aircraft and the structure is very complex, and those load that you have seen earlier will be transmitted to all the structure members, from the large spar or the large frame or large bulkhead into even the smaller stiffness and stringers. And what is important in this design is the failure. So we do not want the structure to fail. If the structure fail, means they are unable to carry out the load and the forces which has been determined earlier. For your information, the weight is the main factor because we design the structure to the maximum takeoff weight. So for A320 is 120 ton, mean the load of 120 ton is to transmitted across the whole structure component of the aircraft. For the Eagle aircraft is 750 kilogram, and we design all the structure with that thinking of the load of 750 kilo maximum takeoff weight. So what is the problem here is we do not want the structure to fail, and we need to determine what is acceptable. So how to be safe for the structure not to fail? The design of structure must have strength higher than load applied to the structure. So you must design something which is higher and your applied load is lower than what you have designed. So what is acceptable margin? The requirement say it is 50%. So if you go to the awareness requirement 25.303, they have specified the factor of safety. Unless otherwise specified, the factor of safety is 1.5. Mean that factor of safety means that the design load over the applied load, we have to have a ratio of 1.5, mean the 50%. So the design load has higher strength higher capability than applied load. So we cannot be lower than 1.5. If you are lower than 1.5, the aircraft is no longer airworthy. So for those who are working on the aircraft, you must be careful on design and of the component, or even you repair the aircraft, you must make sure the factor of safety remain at 1.5, or else the aircraft airworthiness automatically will be invalid. So that is something that we need to be careful with. So this is a design requirement. And the issue now, this is generic. However, when we come to composite, we have a bit skeptical, because 1.5 for metal, I believe, is repeatable. We are able, in whatever way, we able to achieve that 50%. For the composite, there are many variations which we are not sure. For the eagle, in my experience, we do not use 1.5, we put it higher to 2.25. And where are this number come from? This number come from with negotiation with the CASA Australia, because eagle was initially certified in Australia. It was certified under Civil Aviation Safety Agency of Australia. So CASA Australia and Eagle sat down, and we have decided that we use 2.25 instead of 1.5, because there are many variations. So variation means we have unknown, and for your information, the 50% is to handle the unknown. We do not know for the 50% for the metal. Most of the time, we may have errors in materials, quality problem, we have problem manufacturing issues, or error in even the calculation and test. So hopefully the 50% will be able to absorb all these errors. For the composite, there are many more variations, so that's why we focus, for the eagle specifically, is we put 2.25. Because first, the resin system. The eagle resin system is not standard epoxy. We use vinyl ester, which is not many information on this, not many history as well. And also we are doing wet layup. There are probability of voids, even though you do the bagging. However, it's not as higher quality as pre-preg. It still require human to lay up and to compact it before you apply the bag vacuum. And workmanship in placing the fibers orientation 0, 90 plus 45. We do not have. We have to lay. We have. This is depending on the skill of the person working on it. And resin control volume, and also depending on the person how much resin they apply. As you lay up, you apply the resin. You lay out the fiber, apply the resin, and that is also human skill. And also the eagle is still the eagle. We do not do complete analysis. We have not done thorough analysis, and basically we build the part and we test and build and test, and as we satisfy, that is the part that we use on the aircraft. So it's basically very conventional way. It's not using highly software tool for the analysis. So we are using test, most of it by test. So this variation end up we used to use higher factor safety. For other aircraft, for large aircraft like Boeing and Airbus, they have done the thorough analysis on the composite, the resin system, the fibers, and the laminate. Then they have different factor safety. So still the 1.5 is very generic for general structure, and the composite we have to treat it differently. So this is one of the issue when you later on working on composite aircraft. You can't just take this redesign requirement 25303 as 1.5 as such. You have to think of the variation, the potential variation which is not able to control. So you may have to think the higher factor safety. So next, that's what means that we have to look at the design requirement. So it means that as we go looking at the structure up to now, we need to look at sets of requirement, how to certify, because this sets of requirement is a guidance for you to get the design certified. Our purpose is to get design certified and to ensure the design is safe. Later on, I will explain to you there's a new concept of approach in the design certifications. So we are more on aircraft is more on rule-based design or prescriptive-based design. Mean there is a detail. There's a prescriptive, you have to do this, you have to get the structure to hold the ultimate load for the 3 seconds, you have factor of safety 1.5, you have to have 16G load. So those are prescriptive because everything is given to you. Other industry, for example, the marine, they have embarked into the risk-based design, mean they are not uh, restricted to the specific requirement. They have to justify their design based on their risk assessment of the performance requirement of the products. So then, because this is our design is prescriptive or rule based, we have to look at early in the design process because they are very difficult for us to maneuver if we got a problem. And then it's something that we need to follow up to the end of the project. And if you're unable to comply some of it, and it will be very costly, you may end up to do the design, or you have to change the design. So that's why for aerospace design, we have to look at the design requirement at the beginning of the design process because it's very difficult for us to maneuver once you have problem along the way. And it's different from risk-based design because risk-based design is very focused on the performance requirement. So what is there? There is a design requirement, detailed design requirement for the aircraft, which is aeroplane, rotorcraft, engines, propeller, and design requirement was set in the ICAO, International Civil Aviation Organization Standard and Recommended Practices, Annex 8. Annex 8 is airworthiness of aircraft. There are 19 annexes. Annex 1, for example, is personal licensing. Annex 6 is aircraft operation. Annex 8 is very specific for airworthiness of aircraft. And the design requirement, or the IQ call it technical requirement, is in this Annex 8. So if you want to go how the aircraft been designed in detail, you can go to Annex 8 and Section 3 and above, I believe, all about design requirement. So let's see what do they have. Specifically for the, just example, I would just want to bring you to see what is in there. And for example, one of it, if you look at the material, we're talking about composite and we refer to material. So if there is a D13, for example, all material used in part of aeroplane essential for its safe operation shall conform to approved spec. So approved spec. If you are doing composite, what is approved spec? If you're doing metal, it's very straightforward. To composite, the approved spec may not be available, and you have to develop the spec on your own. Then okay, look at the next one is okay, this is a zoom out of the requirement. Next is manufacturing method. The method of manufacturing and assembly shall be such as to produce consistently sound structure. So it's also something, again, in composite we have problem because how to justify it's consistently produced, because you are laying up like the laminate orientation is different from design to design. The environment is different from factory to factory. That's why if you are moving the factory, especially for the composite this manufacturing, we have to evaluate and recertify the factory because of this issue of consistently sound structure. Consistent protection. The structure must be protected from weather, corrosion, abrasion. And weather, corrosion, abrasion could be straightforward. We just put a paint over it and it could be protected. However, can we protect it from the, because the words here, protected against deterioration. What happen if the composite structure hit by stone, hit by gravels? We do have undetected damage. Then how we protect that? Is it a problem for metallic? It's not a problem because we don't have that behavior of undetected damage, which cause huge problem. For this undetected damage, basically, if you study the report which we wrote for the investigation of 9 MIGB, the Tan Sri JJ helicopters crash in Kajang, and that is a pure example of undetected damage. We lost a horizontal tail. So that is how difficult it be in composite. So those design requirement basically is not the IQ design requirement. If you see, it's very brief. Then the country, the state is the US, the European Union, which is under EASA, using EASA, has used those as a basis for them to develop the detailed awareness requirement. What is shown here is the awareness requirement, which is by FAA, which is Part 23 for normal category aircraft, Part 25 for large transport aircraft, Part 27 for normal heli, Part 29 for the transport heli, and 31 is for main free balloon. So 23, 25, 27, 29, 31, and EASA has just changed CS23, CS25, CS27, CS29. So CS is certification spec. So basically, if you look at the standard, compare side by side, they are almost the same. So I just focus more on 25, even though I use some example of 20 VLA, which is very light aircraft. I use a lot of the Eagle because I have a lot of information on that. This is sharing session again. However, the methodology are the same. Only the complexity is a little bit different because of the structure design and also the material. So CS25 large aeroplane, I believe most of us interested on this because we're flying large aircraft, and as we learn the knowledge in part 25, you can easily apply to even lower aircraft. Now, even for example, we will be focused more on unmanned aircraft because more and more unmanned aircraft will be come into the certification. So this knowledge also can be used for the certification of composite structure for the unmanned aircraft. So what we are focused here, we focus on, there are several. So you can see here, there is part, there are sub-part in the design requirement. Sub-part A, B, C, D, E, F, and G. And the structure, I put there, focus, the structure is sub-part C. In sub-part D, design and construction. I won't talk about B, which is about flight performance. E is about power plant, and F is about equipment, which is all the navigation, radios, and electrical system. And G is about the manual. So focus that we today is on the structure. So structure is part C and part D. And also we do have numbers. Numbers, those are paragraph numbers. For example, the structure 301 loads, 303 fatal safety, which I have discussed earlier, and 305 strength and deformation, and 307 pro structure. We'll go through it briefly later on. And we also have 571 damage tolerant fatigue evaluation of structure, 581 lightning protection. We have also several issues on that. And we also have design and construction like 603 material, 605 fabrication method. Fastener, I don't see is a big problem because we use standard fasteners. Protection structure again 609, and 611 is not an issue, and 613. And 619, 621, 623, those are factors for the metallic. And we also will look at 629. I will go through with you briefly on this. So this is a chart. Basically, this chart showing you this from one of the FAA advisory circulars. I did not quote the numbers here, but it's available. Which chart showing you for each type of aircraft, 23, 25, 27, 29. If we talk about material and fabrication, and those are the paragraph number that you have to look into when you're doing the certification. For material and fabrication, development, for example, CS23, you have to look at paragraph 603, 605, 609, 613, 619, and the rest 25, 27, 29. Those are the paragraph affected. Those are paragraph that you need to look at it in doing the certification. And pro structure, statics, and strength, you can see that the paragraph affected. Pro structure, fatigue damage tolerant, you can see the 573 for 23, and the rest for 25, 27, 29 is paragraph 571. And for the flutter also is identical. The number identical, only the between the CS, the complexity a bit different. Continuing readiness, 81529, same paragraph number. Crash worthiness is those are number affected. So mostly the paragraph number are the same. However, you cannot just take paragraph 561, for example here, on CS23 and take it similar to 561. The significant difference is the complexity, because 629, CS29 is for large rotorcraft, for example, CS25 is for large aircraft. So some differences in the complexity to show the compliance. Fire protection, also another issue you have to look at in design certification of composite. There is 609 there, and also 853 is for interior. And lightning protection, I will briefly go through here just for you to get information when you do the design certification, which paragraph you need to go to for each type of aircraft. Okay, let's look at first one, vibration and buffeting. So the structure must be demonstrated in flight free from any vibration and buffeting. This is standard requirement. Either metal or either composite, this is something you have to do during the flight test. 251 is in the part B, flight. During the flight test, during the flight, you must demonstrate the aircraft is free from any vibration and buffeting. So this is not, it's just a generic requirement. Even if you are metal or if you are metallic, also we have to show this. Then factor safety, I have also explained to you earlier. This is standard 1.5. However, most of the time, if you go and see the authority, you say you're doing composite structure and you say you are using 1.5, and most of the time they say just prove to them this is acceptable. If you are doing metallic, you don't have to prove. They won't ask you. You prove to me that 1.5 is acceptable for the structure. If you're using composite, you bring 1.5. Your factor safety, they say prove to us that the 1.5 is acceptable. So the proof is the issue, because you need to do a lot of tests. And strength deformation. So the structure must be able to support limit load without detrimental permanent deformation. So one thing of the aircraft structure design certification is don't allow to have any permanent deformation. So this is a problem, because composite does not deform. However, it may fail already. So that is a big problem, and that is impact damage issue. So that is something that we have to look at. When you look at the standard, it's quite straightforward. Permanent deformation, however, in composite, that may not be the same. You may have deformation, but it come back to normal. Or it just composite, either you break it or no breaking. So that's the issue. However, the interior, the foam, the core could have been damaged, or the interlaminate failure is already occurred. So the showing compliant could be by analysis. So this is one of my work. I'm doing final element modeling and to simulate buckling and elimination of composite laminate. And either you can do by analysis. However, the problem is, if you want to do analysis, you need to know all the property here. So you need to know the property, and this is not isotropic material. This is anisotropic material, because there is a transverse property. For isotropic, we only have tensile modulus, only one number. However, for this composite, you have to have the property with respect to their power direction. So that is a big problem. That's why for the case of Eagle, we just end up testing everything rather than coming out with the properties and then doing the design analysis. So here is also another, I will show you this from time to time. So this is the pyramid from where the certification of composite material. And when I was at Wichita, I visited a place where they've been doing testing to qualify the material for the 777 long time ago. And they have a room full of the uh, specimen of composite laminates because they're doing this test here. So this is a test. Down here is where you develop your property. Tensile, shear, compression, bearing, everything is from here before you go to the next level, which is element and detail and subcomponent and component. So we're talking about the requirement A here, 25305. We're talking about the structure. So you are at already at least level component higher in the pyramid. So imagine that before you go up to here and how many tests that you have to go through. That's why for the 777, I was told during the visit they took 2 years just to get the material properties here, the bottom of the pyramid here. So another thing is here, the next one is support ultimate load without failure for at least 3 seconds. So how do we do that? That's why the test is important, and this is normally the best and the easiest way to do is by doing the test. You're doing the static test, you go to ultimate load, you hold it for the 3 seconds. If the structure does not break, it is satisfied. If the structure break, not satisfied. That's why you look at a lot of videos on the structure test. They are waiting for the test up to the ultimate load and continue testing it and they're breaking it. For the small aircraft manufacturing like the Eagle or like other small manufacturer or for home build, you may use the same part again because you test to ultimate load, then you hold it for the 3 seconds, you remove all the load. So mean the structure is satisfied and the structure test article is being used as aircraft parts. It can be done. There is provision for you to use the test article in the production aircraft. We do it a lot during the SME 3 design and development, design certification project. So this is example of Eagle, this Eagle aircraft, and this is a test. You can see there's a wing here, and we can see all the load applied to here, we call it fur tree. And this load here, we have put a padding over the wing, and we have the fur tree here, and we calculate what will be the forces for each of the padding, simulate the load distribution over the wing, and we pull it up until the wing is break. So you can see here 2.50 limit load. So Eagle XTS wing test case 1 250% limit load. So they go for 250% of limit load. And this is the early development of Eagle. I believe this is in 1992. You can see the photo here, 1992. So then there is also the structure shall withstand any vibration buffeting. So you have to fly to the VD. The VD is a dive speed or Mach D. So you have basically fly the aircraft, you dive it, and at that time, no vibration, no buffeting from the structure. If we look at the 380 development, they have done the vibration and flutter, vibration and buffeting test. The first one they did fail. They flew into Mach 0.92, and after they reach the Mach 0.92, there are some component, there's some part of the structure around the landing gear fail, broken up, and they abandoned the test and they landed and repaired. Almost 2 weeks on the ground, they repair and they flew again, and they go up to Mach 0.96. So that is the VD. They basically fly and dive the aircraft, and This is something which is very unlikely you can show compliant by simulation. And also there is any structure vibration resulting from any failure of the flight control system. Any of the failure of a flight control system, for example, you may have lost one of the actuator, or you must lost one of the push rod, and there should not be any seal vibration and buffeting from any of those failure. Pro structure compliance must be shown for each critical loading condition. So many loading condition of the aircraft, takeoff, landing, landing one wheel, landing, craving, side loading. So all those should be, all those loading conditions should be show compliant that you are not failing with those conditions. And either you can do stress analysis, or you can do the structure analysis, structure analysis by simulation, finite element modeling, and fundamental analysis, or you have to do by test. Whatever analysis that you do, you still have to do some mean of test to substantiate those analysis. Then this is the issue of material. Appropriate material correction factor must be applied to the test. If you do the test, you have to do some appropriate factors into it to simulate that is the real situation. Damage tolerance and fatigue, you have to avoid this issue throughout the operational life of the aeroplane. This is a bit tricky because it's not we do not have standard material SN curve, stress and cycle curve, and this is something that one of the development during the development of the materials is something that you also have to determine. As you develop the material properties, this is one of the area you need to determine. That's why I said the 777 I was told it took 2 years to get the material system. Lightning protection, this is an issue because composite is non-conductive, and there has a problem how to get this to be conductive and how to divert the electrical current. And I will share experience on what we have on the diamond. And basically for the composite structure, they have either layup copper mesh or aluminum mesh as part of the laminate, so to make those surface conductive. This is the main problem 603. So the material used based on the basis of experience or test. So if you do composite, then there is no experience. You cannot say I'm using epoxy and you also using epoxy resin system, I'm using epoxy resin system may not be the same because also depending on your manufacturing process and also depending on your laminate, how you design your laminate. So basically, most of the time you have to come out with the material properties by extensive testing. And also during the test, you have to take account of environmental temperature and humidity. Whatever you think it will be in the environment that affecting the aircraft in service. Again, this is the coupon. This is the pyramid. Again, that's how we do the test from the material properties down to component. And fabrication method, consistently sound structure. So 605. So you must have method which is consistent. For the metallic is straightforward. What do? You cut, you machine, you mill, casting. It's very straightforward. And for example, casting has been around for thousands of years. So it's something that which is the knowledge is there, and we are able to determine, we are able to predict what will happen. For composite, it's a bit different because it's different from resin system to resin system, different from fibers to fibers, different from laminate to laminate, different from your own design. So it's something that you have to develop you have to develop the process specifically, and you have to test, and you must develop the process spec of the manufacturer. So you can see Boeing they have their own manufacturing spec, Airbus have their own manufacturing spec. That manufacturing spec is been designed, has been validated through series of tests, that the test show the process of manufacturing is consistent. So that is a requirement under 605. If you go and certify composite, you go to the authority, say I'm going to work on composite aircraft, you are certifying the composite aircraft, and one of the requirement is you have to have the process spec for the manufacturing, and that has to be justified by several tests, and those spec is to be approved by the authority. So again, I show this. This is the famous pyramid. Protection structure, I have explained earlier, you have to protect the structure from weather, corrosion, and abrasions, and also you have to have ventilation of the structure. We do not want any moisture. There are cases where uh, the there is moisture, water, this air trap between the core of the foam, between the two skin, and then inflate the pop out. So so this is a case where we have of repair. So we have to be very careful on this. And again, doesn't say about the impact damage and because say weather, corrosion, abrasion. But again, the word here be suitably protect against deterioration or loss of strength. So here where we are concerned, using this requirement that we also need to handle the impact damage issue on the composite structure. Design value, material strength, property and design value 613. Here is where you have to do enough tests to develop the value. For example, the modulus of elasticity, modulus of rigidity, your Poisson ratio. You have also to develop your ultimate tensile stress, yields, ultimate yield, compressive yield, bearing, so shear ultimate. So all these material properties has to be developed under the requirement of 613. And imagine this is not isotropic material. So this is anisotropic. So you have to have the value for the direction of the plies, and also you have to have the value for the laminate. So the structure been designed to a specific laminate, and then for the each structure you have to develop, for example, the wing spar, the wing skin, they could have different value because depending on the direction of the fibers being used in the laminate design. Again, famous pyramid, we have to do the test. Aeroelastic stability issue mean this is the structure. This is some advantage here on composite, because for the metallic is aeroelasticity is depending on the mass and the stiffness. So the parameters of aeroelasticity, stability is mass and stiffness of the structure. For composite, you can design the stiffness of the structure. You can design the stiffness of the structure towards your requirement. So basically, for the aeroelastic stability, if you have a good design, then this issue will be less for the composite structure. Bird strike is also something is very significant. They shoot the bird. We need to get 4 pound bird to satisfy the requirement, and they treated this same as metallic. They shoot the bird also, but again we go back to the problem of the composite, and because of the hidden damage, it may have the impact and the damage may not be seen. But for the 4 pound birds, I think it's can easily damage the structure. I've seen the radome been punctured through by these birds. Okay, now design requirement summary. So the summary is, if you look at this coupon, this pyramid, you can see 25631 bird strike here is basically at the component level. Okay, you have to show compliant 25631 at component level. Aeroelasticity stability at component level. Material strength property 25613 at the bottom here. Material strength properties and material design value. So that is 25613. In 609 is a component level. At the material selection itself, 25603 is based on focus on this bottom of the pyramid here. For fabrication method, it begins from the elements, how you make this element, from the detail element, from the sub-component, from the component. So 605 fabrication method, you follow through from element, detail, sub-component and component. And each of these phases, you have to develop a very detailed process spec. Process spec means the manufacturing process spec, which has to be approved by the certification authority. So for rotorcraft, basically this experiment here show the detail of the rotor blade design and certification. So since we can say that rotor blades are component, and you can see the pyramid. If you move up to the pyramid, is almost the same as the aircraft structure, except this is focused on the rotors. Okay, experience. I have problem. We have experience with Eagle resin system. First, this is not standard epoxy. This is vinyl ester, and we have not many reference on this one. We have to develop the resin system ourselves. We have to do a lot of tests. This test is not the pyramid test. The pyramid test is looking at the properties, but here is to perfect the system, the resin, the basic resin, and the catalyst hardener, which is the best combination, the best ratio for us to have a good gel time, because we do not want the because we use a well layup, we pour the resin in the bucket, and then we use a brush to brush out. We do not want as we pour in the bucket and then the resin harden. So we have to have some time. We have to calculate what time, how long we can complete the whole wing, and we need to make sure the resin is still be able to use is not hardened after the time we finish doing the wing, for example. Those are the activity that we do a lot in perfecting the resin. So not basically focus on the material engineering properties. So that is a lot of work. And because most of the structure satisfied by tests, and we do not do the thorough analysis, and we don't use those property, we don't use the modules elasticity, we don't use the tensile ultimate yield, tensile yield, compressive yield, compressive ultimate. We don't use the shear value. So we just build and test, and as a pass, those are certified by. So the challenge is we have to test everything. As you make a changes to the part and component, we have to do the test, because we do not have any uh, basis to reanalyze or redesign. And also we do extensive burn test. The formulation, again, we're talking about gel time. We also have to do certain resin, specific resin system for us to use in the cowling in the firewall area. So basically, this formulation, not just on gel time, also we are also would like to look at how fast this thing can burn. So lesson learned from those development we are small. We have not much fun. So if you do the certification process by looking at the material properties, look at the pyramid, at bottom the pyramid, that take years and also very expensive. And we just do tests, it's cheaper. However, during the redevelopment or during the modification or repair, is a nightmare, because you may end up to build another part and to retest again. So that is lesson learned from this kind of approach. So this is test. We test almost everything. Eagle aircraft is a VLA, and VLA basically does not require to show fatigue life. We have the design principle of very light aircraft is you have to design everything below the fatigue life threshold. The problem that we have is we are vinyl ester. All the data that available is graphite epoxy, carbon epoxy. So now, what is the fatigue threshold? And we can't justify, we can show that to the authority, to the CASA, and CASA end up say, you do the test at least at coupon level. So we develop a test plan to determine the life of the Eagle aircraft. And the test at the coupon level, as we start doing the test plan, we have problem because we have problem on the basic issue because we do not have the fatigue life spectrum, the aircraft flight spectrum. The flight spectrum is the basis, is a load, load into the fatigue test, and we do not have that because we are just VLA, we are just no one in the market at the time, and no one collecting this flight spectrum. And the flight spectrum basically require 2 years of flying, and those 2 years of flying depending on which kind of flying, where you're flying. So we have problem with that. However, CASA is kind enough for us to use the one of the SAE paper. That's where I started to be to admire these papers produced by the academia, because these papers save us from going through a flight test to develop the flight test flight spectrum for the Eagle. So we use the paper, and the paper basically was published for Piper aircraft, because Piper aircraft having fatigue problem in Australia. So Australia CASA has flown the aircraft for several years to collect for the flight spectrum specific for the Piper operation in Australia, and they recalculate the life of the wing of the Piper, and then we use that as our test spectrum. So this is what the flight test plan, and we work with the CRC Australia, Composite Research Center. I don't know whether they still exist or not. So I was preparing in this together with the CRC. And what we did, we have coupon. We developed 6, 10, 12 coupons, and 2 undamaged, 2 impact damage 20 mm, 3 delamination 20 mm, and 2 lap joint, and 2 impact damage 20 mm. Okay, so impact damage 20 mm, delamination. Impact damage, we do the impact because CRC having the machine to do the impact. For the delamination, we put the 20 mm Teflon inside the laminate. And there's a length specimen, and this is the remark on the each specimen. First specimen is control specimen, undamaged, clean, good, no issue. 3 represented impact damage, and 3 represent delam, and 2 joint, lap joint, and 15%. So the last one is 15% overload specimen. So on the impact. And this is a 3 ladder type. We have put all these specimen along this, and we cycle it up and down. Okay, we do the cycling here. And for another set, we use to simulate the environment. We put in the humidity and temperature. What we did, we capsulate this with the plastic, and then we apply heat, and we put water, we spray water into it. So that is another set of the test. So this is a fatigue test. And we also have problem on UV. We have been questioned on the UV, ultraviolet radiation effect. So what is the effect on the resin system? Remember, we're using vinyl ester, and not many knowledge on the vinyl ester. We end up to produce, we have to end up to justify. And what is the effect on the UV on this vinyl ester? So what we did, we have a UV test program. We built 4 serviceable flap. 2 in we put 2 in Malacca and 2 in Perth, and every year we do the inspection. If we see any form of deterioration of structure, and at the end of 2 years, we test this flap, and we would like to determine whether any degradation in the strength. I think the test has not been completed because the Eagle program has ended sooner. And supplier, okay, back to composite issue. Composite is very critical to the supplier. We have to control the supplier, and the issue now, the supplier is international supplier, so we are unable to go on site to audit. So this issue was brought out by the FAA during their audit for us for the BASA program. So again, for composite, for you working composite, you must also be careful on the supplier. You may have the technology where you may happily use the resin, but you have also to determine the supplier to be controlled, uh, that you are able to provide a consistent product. Lancair, the Columbia, the Lancair LC40 5550FG. We did the. I was at DC at this time, and we were doing the Lancair project. Supposed to come to Malaysia. It should be the second aircraft project for Malaysia, the third aircraft project after Eagle and SME. And however, this project was stopped in the US. So we have involved in the early development of this Lancair project, and the early development of the aircraft. They have problem with the glass transition temperature because it's very close to the ambient temperature. Then and we have to prohibit aircraft flying if the temperature is reaching too high, nearing the TG. Then we have to couple there and we look at the temperature, what is the reading, and we don't fly the aircraft. So the problem here is for this kind of aircraft, we have greenhouse effect because this is canopy type of aircraft, same with the Eagle. Greenhouse effect means if you close the canopy, the temperature inside is higher than even the outside ambient temperature. So that is a problem with this kind of canopy type and also this kind of aircraft. I believe this temperature, this resin system has been resolved. I don't think there's any problem with this anymore with the Lancair. So this is about the resin system. Diamond 40 also the same. There's also issue. The first development of diamond, I was doing the type validation for the diamond. They also have the same issue on the TG. So they have prohibit other than white. So you cannot paint diamond other than white. You may see that now diamond has been painted other than white because they have changed. They have improved this TG, glass transition temperature. Glass transition temperature, sorry, I forgot to explain to you. Glass transition temperature is a temperature where the resin start to deteriorate. And if your ambient temperature is close to that, mean that you have the potential of the resin system breaking down and failing. And we have to design so that it will not near the can satisfy the temperature requirement. And also issue on the diamond is there is a composite aircraft, non-conductive, and you can see here in the diamond, and they need to ground those all the equipment, and they have aluminum tube along from nose to tail, and also there's some area of the laminate they have interwoven aluminum fibers integrated into the laminate to make the surface conductive. Devoted locker is the last project I was involved. Devoted locker is why I put it here because this is an example of something with no design requirement. So it is a box to put firearm and ammunition in the aircraft. So what they did, they put this in the cargo compartment. So they put the gun ammunition inside here. They lock it and only can be opened when they landed to another airport. So the problem with this is fully composite, and there's no requirement for this. There's no design requirement, and there's also no clear definition whether this is a aircraft part or what is this. Is it just another baggage? But however, for the certification, we need to have some basis. There's an example where you need to have the basis because without the basis, we cannot certify. The certification must have a basis. So this, what happened is we are having a headache how to get this certified, and we negotiate with the authority, say this is a galley compartment. So we use a galley compartment design requirement to certify this diplomatic locker, the box, and we do all the tests. We don't go to the pyramid and go to determine the material properties, engineering value for this, because we just do tests. We don't have to do that. So the test also focus on the strength of the lock and also the hinges, because the requirements say any item or mass inside should not dislodge out after the emergency landing or any weather disturbance. So we satisfy the test. So this is quite a good project. So in summary, again, for the certification of composite, we shall begin from the bottom here, where you need to develop the properties for us to do the design. You need to determine what is the stress, what is strength, what is FTU, FTY, FCY, FSU, modulus of elasticity, FBRU bearing, FBRY. So those are here, and those value is used during our stress analysis. And imagine this value should be depending on your laminate design, and should be because the anisotropic material. So you need also to determine the direction of longitudinal and transverse direction. What are the value? And this is very complex, and there's a very extensive test. So if someone come to me asking whether they wanted to design a composite aircraft, I said be prepared to work on this level, because this is the basis of your design. You have to start from the bottom here before we move up to the component and sub-component. And here on the right here is explaining to you the paragraph in the design requirement. Future, what is the future? Future is just like everything else. People in the past do not think of aging aircraft, and do not think of the TW800 aging wires, aging system. Everything is aging because aircraft been operated beyond their design service goal, design service life. So what would happen to composite? Is the resin system will be there forever? Is the resin system breaking? Is it the fibers breaking up, deteriorate with time because of the environment? So that's one. Second, the design of prescriptive. Design of rule-based are no longer applicable. It's no longer acceptable because it hamper the new development of technology. There's no innovation because everything is prescribed. When everything is prescribed, you have to follow. If you don't follow, you don't get the certification. You cannot introduce a new innovation, new technology. It's not easily be introduced. You can introduce new technology, but it can be very lengthy process to show compliance. So now the focus more on risk-based design certification. For the CS23 and FAR Part 23 for normal aircraft below 5007, they already totally changed the design requirement, the awareness requirement, into risk-based. You don't see anymore the fatal safety 1.5. It's just very simple. The structure must be safe. How to be safe? You have to do a series of risk assessment and risk analysis for you to say this is safe. So this is a new design requirement, a new design concept, risk-based design certification, which has been used a lot by the marine, and for the building services, they have been using performance-based design. So in future, prescriptive and rule-based design will become something in the past. However, in aviation, still we already start to go into this at the level of normal aircraft below 57. You can compare the old design requirement and the design requirement now. It's totally different. And also now, with the latest CS-UAS, certificate spec, unmanned aircraft system, they also use this risk-based design solution extensively. So I think that's the end of the session. So I hand over back to the moderator. I go to the first one.
Yes, please, Prof.
Ricky, composite has taken quite a big chunk away from the conventional metal design airplane. Yes, true. Now more than 50% of the large transport aeroplane are now from composite. Whether that is a future, yes. Whether that is no problem, there is a problem. Also metallic manufacturer, suppliers, manufacturer now also coming out with some kind of super alloy, super aluminium. They also introduce metal, they call it hybrid composite. They have aluminium and carbon laminate. So okay, we cannot run away from this composite, because composite, one thing about composite, is easier to manufacture. I've seen a Cessna in Wichita. There's one person building flaps. There was the early stage of the composite manufacturing, and they take 3% to build metallic flaps for the Cessna, 1% to build a flap for Cessna, 1% to manage to build the complete fuselage of Cessna jet, because the Cessna was automatic layup in the mandrel, and they just those automatic layup in the mandrel. They just roll the mold to make the shape of the aircraft, and they later on they cut the doors, they cut the windows, operated by one person inside the room. So imagine that, how easy to make things from composite. That is why composite become something in the future. Like everything else, technology, there's a problem. I believe that is the job for us in academia to study what is the problem, and probably and in advance we know the problem, and we try to come up with many papers to solve the problem. Next question. Sorry for the disruption. Thank you for your patience. Okay, Dr. Rahim. When were you in Wichita? Wichita, I was in Wichita in I was there for attachment with the FAA Wichita. I can't remember, it's too long ago. I think around somewhere in the 90s. Yeah, I think maybe at your time. Yeah, I visited one of the center. They are doing tests on the composite. I think it's one center they also forgot. I was in the yeah, I can't really remember. It's a long time. It's more than 20 years. Dear, can you tell, okay, Prof Rahim, info, right? And then Assalamualaikum, Prof Abdul Rahim, please permit me. Yeah. I'd like to leave, okay. Terima kasih Pak Harry, thank you, Harry. Salam Prof, I have two questions. Why Eagle decided to use vinyl ester considering the lack of test data? Okay, why we use the vinyl ester? First, it's cheap. Okay. Second, it's easily available, because if you see where the Eagle was, we were at the boat factory. If you go to Fremantle, you go south going to Mandurah, we are along the highway to Mandurah, we are on the shipyard area. We was next to Wave Master, was owned by Amin Shah, doing the catamaran. So basically, Australian area like Perth area, Fremantle area, they are very familiar with boat industry, and they use that vinyl ester. Vinyl ester is used a lot in the boat. I believe the earlier development of the Eagle, they use vinyl ester because of the cost. It's cheap. Test data. Even though we use epoxy, we still have to do a lot of tests. So you cannot run away from the test. From Karim, question 1 regarding slide 52, the flutter criteria vibration is covered up to element level. Does the flutter criteria also validated through flight test? Yes. Flight test is ultimate. However, before you finalize your design, before you go to flight test, we should have some knowledge of what would happen if you do the flight test. So that's why the analysis, the pyramid up to the component is very important for us not to have the surprise. Even the 380, the early development, they have also problem. When they flew at 0.992, they have failed the structure. Imagine how much cost for you to fly the aircraft. Fly up to 0.92 with the pilots, with the flight test crew, all the insurance, is very expensive business. Even Airbus get caught after all those process. So yes, the final certification for flutter is by flight test, not by component, sub-component. Number 2, in composite stress analysis, will it be failure criteria to be chosen during the airworthiness certification? Who, he? Yes. For design analysis, yes. However, for your information, the final certification is by test. So the analysis, the simulation, just for us to have some indication, some confidence that it will not fail during the test. The analysis is straight analysis, just like textbook analysis. Yes, it's not an issue. However, for the certification, it still have to go through the test. And this analysis is very good because if you pass the test, you do the analysis, you use the failure criteria, psi who, psi here, everything you do it in the analysis, and you did the flight test, you did the structure test, everything is passed. Mean that those analysis has been validated, and the future development we can use those analysis as a basis. 3. Does the von Mises criteria composite is significant criteria to be looking into in the stress analysis? Whatever technique, whatever theory and stress analysis we use in composite. Again, this is not something we use for certification. We use as to give us a confidence. The test will pass and we'll have no problem during the test. So the standard stress analysis is just like any other structure stress analysis. Even though it's more complex because we have this laminate. Yes, however, the theory is the same. Kian living, yes. Some Prof, your opinion, what is the next technology advancement in aerospace composite technology? It seems to be breakthrough material, almost stagnant up to now. Okay. Technology is demand. Technology has cost. And technology also come with the needs. So as far as we in the is academia, we do not think of the cost, we do not think of the customer. We want to develop technology. If we think of that, there's no academic breakthrough. If we restricted by what the demand out there, it will be no breakthrough in academic. But out there is about money. So this is you need to balance the technology and the cost. So I believe, for example, the first time they developed the Witchcraft Starship, they think composite is a super material. Everything from composite, 100% composite. End up the aircraft is overweight. So this is something. So talking about nano composite, yes, I think as far as academic, we can do a lot. However, how much? First obstacle is a cost. Can the manufacturer absorb the cost of manufacturing of this new technology, introduce the new technology? And thirdly, can the authority be able to support the certification of this new technology? There are a lot of unknown, then become very expensive because you need to do a lot of tests. Prabu, Rahim, your question. Where can we get the data from the aircraft? Is it available? Okay. All right. Okay. Now, I think the Eagle, I don't know what this is, the Eagle. It's almost like, it's not certified. I mean, it's not like, I don't know, the company also no longer there. Rahim, you may talk to CTRM. I suggest you talk to CTRM, and then this is very important here. It's very, very, very good question. You may want to secure all the data, if possible, because we do not know where they are, whether they've been kept or they've been thrown away. We don't know. Okay. Similarly with the SME, we got two now. We got SME and we got Eagle. From your channel, from your network, from your capacity at university, and from your whatever influence that you have, this is something you may have to think of. Maybe the caretaker the data and you use the data for the academic use. It's very important because we generated a lot. The knowledge we generate from this project is a lot. Basically, we are ready to make bigger aircraft. Okay, but however, the person is retired and has been. Okay, next, Salam Prof. Is there any regulation unmanned aircraft, human powered vehicle? What category? Okay, Hanifah Hj. Okay, for the unmanned aircraft, yes, there are 4. For below 150 kilo, we have CS certification spec. LUAS, Light Unmanned Aircraft System. CS LURS, Light Unmanned Rotorcraft System for rotors. And for multi-rotor, we have Light Unmanned Rotorcraft System. They also now have published recently, which can go up to 19,000 pound and 7,000 pound. 17,000 pound, 7,000 pound, sorry. They have developed CS, Certification Spec Unmanned Aircraft System. And also, if you have problem in certification of this, they also use JAR VLA, Very Light Aircraft, and JAR VLR, Very Light Aircraft. So you can negotiate based on your design. So yes, it's available for unmanned aircraft system. Human powered vehicle, human powered aerial vehicle, human powered mean pedaling. Okay. The significance of the certification requirement is for you to get the certificate of airworthiness, certificate of flight approval. For human-powered vehicle, you may want to fly experimental, you may want to fly within a certain area. Maybe you have to ask special permit, so you may not have to apply using a standard certification requirement. You can negotiate with authority. You tell them that you're building something, you fly around the area, and that could be sufficient. Example, human-powered aerial vehicle. Human-powered, okay. What category they fall under experimental? And Ahmad Yusuf Salam, will be interesting to know what is the large OEM like Boeing, Airbus are seeing the possibility of shifting to race situation in future. It could possibly be combination between two race-based and prescriptive, depending on component of the race associated with them. If the key factor. Okay, this is a problem here. Race-based is require knowledge and experience. Rule-based is what is the past experience. What happened in the past will be the requirements. And one of FAA guys said, if you read through the design requirement, FAR 25 for example, you can map each of the requirement, there are some injury and death. For example, cabin safety requirement, there are people died, there are people injured. So because the requirement came after there are accident or incident, that's why the focus now, like everything else, we want to prevent, not you can't prevent them at all. Minimize those by looking at the risk, because prescriptive with the new technology, we are basically most of the current rule base is no longer applicable. I did ask my student to study this design requirement, and we map the current design requirement. For example, A320. In the certification, if you are unable to get the current requirement in place, the authority will impose additional requirement. They call it special conditions. If you go to type certificate data sheet, you go to certification based on the aircraft, you can see column, there's a paragraph of, they call it special condition. Special condition is over and above the current design requirement. And I have students, I asked them to do as final year project. He mapped out the A320, A319, all the Airbus model, and we found there are the biggest number, we even up to 49 special conditions on top of the current CS25 for that particular model. So mean that the current design requirement unable to support the current technology or the current design. That's why I believe that is the reason why they go to the race-based. EASA has been advocating this race-based. It's easier to do on light aircraft, FR Part 23 or CS23. However, we talk about 25, 29. In doing the race-based, you need to have experience. So it's difficult for us to get the people to come around and doing the analysis. And also easier for us if you want to do shortcut. So if you study the 737-8 MAX issue, if you go to risk-based assessment, I think you can see the problem earlier. I think they did it. I don't think they don't do it. They've been doing it, but again, maybe it was not. I don't know how it would happen. But to me personally, it could be the culture now. We should go for risk-based. Okay, any more questions? I think that's all question that we have.
There is one question in 724 from
I cannot clearly hear you. I don't know why the voice is decaying. Maybe you type.
Now,
Yeah.
sometimes
Maybe your mic. I don't know what. Your voice. Maybe Pro Rahim, can you hear Siva?
Not really. I'm also hearing very low voice there.
Okay.
Question from Zulfazli 734. Okay, let me just find
Okay.
Zulfazli.
734. I don't have 734.
It's 1124.
1124.
1134 is Abu Dhabi time. Okay.
my time.
I think Prof Abu already answered this about why Eagle decided to use vinyl ester.
Yes.
Okay.
Cheaper. It's a
Yes,
boat.
cheaper. Okay, Prof Abu, I think your suggestion for us to ask CTRM for the test data from Eagle Aircraft, it is quite good, and we'll try to request officially on behalf of the universities in Malaysia, and we hope to get the data for the benefits of the academic, right? And it's also because it's very, very valuable experience.
It's not just the data. You may want to request to be the caretaker of the whole type design data. First, you got space. You have a safe space, and space is money. So you are putting it somewhere. It costs money, but in return, you may ask the privilege for your students, for master, PhD, or graduate student to sifting through the data and to learn for future project or for research activities.
Okay, thank you. We will get back to you later on.
Yeah, I saw there was one fatigue test rig somewhere in the SME hangars before, and I think it's been sold somewhere, and I don't see that anymore. Basically, that rig we can rebuild and we can use it again because it's standard rig. We can put any wing. We have to just repair, change the mounting.
And if anybody else any questions,
I got one here from Hafiz. I noticed FR26-2 limit validity nil, LOV available for 7873 airplane.
Prof, can you hear me?
Yeah.
Hafiz from Malaysia Airline.
Yes.
You know me, I think.
Yeah. I know you. How are you?
Yeah, okay. Since the A350 and 7 is a composite airframe type, so I see there's no limit of validity available in the FAR. So basically, our question is: this airplane are already in service for quite a few years. So in terms of this LOV and also the AJ aircraft safety rule, how are these airplane complied with?
Okay, I believe from my understanding of FR26 or CS26, that is for the aging aircraft. So 787 and 350 is a new aircraft, even though it's been around for many years. But I don't think it falls into category of aging aircraft yet because FR26 and CS26 was published after they realized this aging aircraft is an issue, and we need to have the aging aircraft program.
So meaning to say they are still working on the.
They're still working on it because not enough data. If you're working on 727 Boeing, 747 to operate, they have to have aging aircraft program. That's mandatory as part of the operating requirement, operating approval. So that's why we there is FR26. 26 basically came after the TWA and there are a lot of catastrophic failure due to this age aircraft.
Okay, noted. Because of I see the A380 in the list, so that's what me wonder. Maybe because of the composite in nature, how they are going to calculate the fatigue based on analysis and test.
Yeah, I think it's still new. I mean, still they need to study because LOV come, I think, nearing their DSG, right?
Yes, correct.
They didn't come up with before. Okay, okay, Fiz?
One more thing, Prof.
Ah,
On the composite structure, the what call it the landing strut protection.
hmm,
So it's interesting to know lah because of the metal we know is a good conductivity, but in terms of when it comes to composite, the
hmm,
behavior is I would say unpredictable lah because we off record lah we have a few issues.
hmm,
The cowling of the 50 got landing
hmm,
strike somewhere, so the damage is quite severe lah. So
hmm.
that's one thing that need to be considered when it comes to composite lah.
I cannot really hear you. I think you're talking
The landing
uh about the lining protection. Okay,
Yeah,
for
Prof,
the
I
lining
think
composite
protection,
frame.
I think when you do
yes.
repair, you also have to put the layers of mesh, copper mesh or carbon mesh, depending on the design. You put it part of the laminate of the repair, and then you also have to do, I think, conductivity test from the repair patch to the sounding, so should be continuity,
Yes,
right?
correct, Prof. Yes, correct.
Correct. So the issue now is the issue now I can see now is the training of the people doing the repair. Do they aware they have the importance of this, and they have to be very careful in doing this, or else you won't get the continuity. And do they understand this message for what? I think those are the issue that we need to address.
Yeah, so there is a market for composite specialists nowadays, which is
Mm,
sorely lack in Malaysia, I think.
mm. Okay. Thanks, Face.
Okay, Prof.
Nizam Nazar, yes, Nizam Nazar on board. He was one of the CDE design engineer for the SME. He said that test rate gone. So it's very sad to hear that. It was very good. I was eyeing it. I was not at the university at the time, so I would have no local standard to ask for it. If I was at university at the time, I said, give it to me. Yeah. So yeah, very nice, very good. Still, the actuator still there, and I don't think it's difficult to just do it again. And Pro Rahim, if you're interested, I may suggest you may establish structured test laboratory.
Good suggestion, Prabu. We look
MIAT
forward.
and UPM, we develop a structured test laboratory
Mm-hmm.
because at the moment I also did involve with some activity which we are doing repair beyond SRM. So we develop our own repair. However, again, like everything else, we need to justify, we need to show this repair is workable. So we have to have a place where we can do the test. And I got a friend who went to Thailand for interview. In Thailand, basically, there's one company, I forgot the name. They repair everything. I mean, there's not wrong. They develop their own repair and they justify the testing it. For example, repair by welding technique. So they develop another piece equivalent and do the fabrication and everything, and the test in pass, and then they use they work on the actual part. So they do repair development design, repair development or something like that. And we did that also here. We did one MRO here. Was doing heat exchangers, which this heat exchangers basically was scrapped, and then this MRO is not designed, basically just cut out the core and put a new core, and happen to be first we have the skill to do the welding, second our level is cheap for the welders, end up this MRO become the center of the world doing the recore. So this is another thing we need to explore, the repair technology. Similarly with the composite. Okay.
Prof, I have one question for myself.
Yeah.
This is just to compliment Encik Hafiz for memories just now. They asked a
LOV.
question about
Yeah.
landing strike. I think because the A350 and the 787, they are fully composite and they are quite prone to lightning strike. And we in Etihad Airways also have been experiencing quite bad compared to our 777, 787. The lightning strike is it's like so susceptible to it. We don't know the actual reason. Actually, Boeing has not given us a proper answer. Besides the wire mesh, the way designed, there is also they also do a current return path.
Current return path. Yeah.
Yeah. The
Yeah.
bonding between the composites. Do you
Yeah.
think that could be a major factor which is causing this problem as well? Dissipation of the static electricity is insufficient.
I cannot really comment on that because that is we need more study. That is a thing. Okay, as far as design is concerned, there's a thing like I said. Remember, I was talking about the factor of safety.
Yes.
So at the time that we do design, we know what we know at that time. Similarly with 7378 Max, I'm not surprised. Aircraft crash, people died. That is a pity. However, at time design, we only know what we know. But if we are scared to do it, then there's no innovation, no design. So that's why in the past, what we have is the prescriptive requirement, prescriptive, rule-based. That's why the future, that's why EASA realized that it's not enough. What if you read the document why they are go for risk-based, that is how to introduce innovation and new technology. So what you said, what you have experienced, that is something that we don't know in the past. But as you operate the vehicle, we have this problem and we have to address the problem. That's why it's mandatory for the aviation industry. It doesn't matter which organization, MRO, DOA, POA, CAMO, they have to comply to the requirement of in-service difficulty reporting. They have to report all the in-service problem. So this in-service problem will save the future, will save the unknown. That is how to address the unknown. That's why the system must be working. However, for some country, they just think this is regulatory requirement. So they don't use the data. The regulators don't use the data. The OEM obviously they will use the data because they are very interested. They have the interest on this for their product improvement. The approval organization also just say, oh, this is a authority requirement. I just so and sometimes this is not serious. We don't give to them. But this is very important because this is how to address something that we do not know during our design. That's why this is mandatory. I audit thing during my DC time. If they don't do this, I put in CR level 1. This is important. That's why for the design with this system, I'm very confident that we can able to understand what we don't understand based on this system because we can capture whatever in service issue which may relate to the design issue.
Very true. Very true.
Okay.
Okay.
We got problem 747 400. We got section 41 problem. We got 787 battery fire. We got 7378 Max. We got A320. The biggest problem they have, the rack is not working. Deploy not working. So we have problem everywhere because, like I say again, what we design to what we know at the time.
Exactly. Very true. It's
Okay.
like what you said, in-service experience and reporting culture and reporting system.
Yes.
Vital.
That is to be improved. Yes.
That is correct. Very good.
Yeah.
Does anybody else have any questions? We have another 4 minutes remaining before we end the session.
I think is everybody
Everybody is
now.
contented and happy with your presentation. You have done a marvelous job.
Thank you. Thank you. Thank you.
Yes. Okay, and I would like to thank the speaker, Prof. Abu, for his really wonderful insight that he has shared with all of us. And also to all the participants, thank you very much for joining and asking these really valuable questions. And I would also take this time to thank myself and Prof. Dr. Rahim for his time and also for organizing this webinar. It's really resourceful and useful to the society and all the engineers.
Thank you.
Thank you very much.
Thank you. Thank you. All the best.
Thank you then. Have
Thank
a good
you.
day.
Thank you.
Salam, terima kasih.
Okay, thanks.
Okay.
Prof. Rahim, thank you.
Right, terima kasih Prof. Abu. Thank you very much. Special thank to TS Siva all the way from Abu Dhabi. He's hosting moderating the session from Abu Dhabi. I think it's 6 a.m. in the morning over there when we started the session. So thank you for TS Siva. Of course, thank you very much for Prof. Abu for sharing the session. And probably I will try to share the recording of this video for the benefit for others who have not yet able to join. I think we had around 62 participants live today. Very good number.
Thank you. Thank you.
Okay, thank you all. Thank you.
Thank you, MySET.
Yes.
Thank you, UniKL.
Bye bye. Assalamualaikum.
Assalamualaikum warahmatullahi wabarakatuh.